Hello students, today we'll talk about capacitance of parallel plate capacitor. We'll derive its expression and we'll see limitations of that expression. So let us start. To understand today's topic, we need to recall some of the following points. We know that capacitor is any conductor of any arbitrary shape and size which can hold charge. So capacitor is basically charge storage device. And for any capacitor, the capacitance C can be given as Q by V, where Q is charge and V is potential. Most of the time, when we talk about capacitor, we have two conductors separated by some distance, and because of two conductors, charge holding capacity of the capacitor increases because the two are having opposite charges on them, and so you have a very strong attractive force which reduces potential, increasing capacity. Capacitance of any capacitor can be measured in terms of farad, but as mentioned earlier, farad is too large unit, and so most of the time capacity is measured in terms of microfarad. And we also know that capacitors may be classified in terms of their based on their shapes or based on the medium between two conductors. So with this prerequisites clear, we can start with the topic. So, suppose we have a large plate and we want to deposit negative charge on it. Now, when we deposit negative charge on it, because of the repulsion, the potential will increase. And if potential increases too much, we can't deposit more charge. And to solve this problem, we keep another plate, another conducting plate parallel to it, and the other plate is connected to ground. What is the advantage of doing this? Advantage is when you have another plate connected to ground, from ground you will have positive charges deposited on the plate, or else you can say that electrons of the plate will go to ground, making it positively charged. But then how it affects the uh, plate with negative charge? Potential of this plate decreases because you have attractive force between the two, and hence potential overall decreases. And so according to this equation, C is equal to Q by V. If potential decreases, charge holding capacity will increase. So this assembly is called parallel plate capacitor. And we'll see uh, how do we find out expression for capacity of this capacitor. But before we get into maths, let us check logically that which parameter should affect. Now, it is very clear that if you have more area, if plate area is more, capacity is more, so C should be directly proportional to the area of the plates. And what about D? What about distance between two plates? Now, if you increase D, then the attractive force will decrease and potential will increase. So, C should be directly proportional to 1 by D. So, but the essential thing is area and distance between plates is important. And in the expression, we should have A in numerator, we should have D in denominator. Maybe D square or D cube or root D, but there should be D appearing because it affects capacitance. And similarly, A is also important. So when we derive expression, we'll verify the expression with these predictions. So let us start with the derivation part. In case of parallel plate capacitor, when we place the plates very close to each other as shown here, suppose the charge on positively charged plate is plus Q and the other one is minus Q, which kind of electric field we have? Now when the plates are kept very close to each other, we have field lines going almost parallel to each other, and hence uh, if we consider the uniformity, we have very uniform field except slight non-uniformity at the edges. But if you compare the non-uniformity, it is very much negligible as compared to the uniform region, and hence we may consider the field to be almost uniform. But if you consider the plates which are far apart, like in this case, now here, just like previous case, we have many field lines parallel to each other, but at the same time, if we look at the edges of the plate, there we have field lines which are not parallel to each other, and then non-uniformity increases. So we'll derive expression for capacitance of parallel plate capacitor considering the plates to be very close to each other, because then only we can consider field to be uniform, and then only we can use the expression for electric field sigma by 2 epsilon 0, because if the d is very large, we may not be able to use that expression. Consider a parallel plate capacitor as shown here, and in this case we have uh, area of the plate as A, and let the charges be plus Q and minus Q. And how much is the distance between the two plates? Let it be D. We'll assume that D is very, very less than A, and so that we may consider the field to be uniform. Now we know that field lines come out from positive charge, and field lines enter into negative charge. So here, if I consider the distance to be very, very less than A, this plate may be considered as infinite plate, and then electric field of positive charge plate can be considered to be sigma by 2 epsilon 0. Similarly, field lines enter into negative charge. So, how much is the electric field due to this negative charge on this plate? It may be considered as sigma by 2 epsilon 0. But as the two are in the same direction, the resultant electric field can be found out by addition of this two. And hence, the resultant electric field is sigma by 2 epsilon 0 plus sigma by 2 epsilon 0, that is sigma by epsilon 0. And if I consider charge to be Q and area to be A, I can define surface charge density as Q by A. So with the electric field, first we'll find out potential, because we know that potential for uniform electric field can be given as ED. Once we have potential, we'll use formula C is equal to Q by V, and we'll use the potential value there, and that is how we'll find out capacitance of this parallel plate capacitor. Let us see. So now we have electric field, and we have formula C is equal to Q by V, and we know that potential here is ED. We can find out potential with the formula electric field into distance, and then potential is sigma by epsilon 0 into D. And let us substitute it in the formula for capacitance. We know that C is equal to Q by V. So what do we get if I substitute potential value there? What we get is epsilon 0 Q upon sigma by D. But we know that sigma is Q by A. So if you substitute Q by A instead of the sigma, what do we get? Q will get cancelled out, and what we get is epsilon 0 A by D. This is the expression for parallel plate capacitor, and which indicates that capacitance is directly proportional to the area which we predicted, and it also shows that capacitance is inversely proportional to the distance between two plates, because if you increase distance, the charges would not like it, their potential will increase, and what if the potential increases, capacity will decrease. So it is very obvious that d is appearing in denominator and area is in numerator. One more thing this expression indicates is that if you change medium between the two plates, you can change capacity. So right now we don't have any medium between the two plates, it is considered to be vacuum, but this expression indicates that if we change the medium, we can alter the capacitance. We'll do that later in the forthcoming topics. Let us conclude now. So now we can say that the capacitor is a charge storage device, and it is given as C is equal to Q by V. Capacitance is given as C is equal to Q by V. The capacitance of parallel plate capacitor can be given as C is equal to epsilon 0 A by D, but don't forget that here we are making one assumption which says that D is very less than A, and if this condition is not satisfied, we will not be able to consider field to be uniform, and then this equation epsilon 0 A by D may not be applicable. So be careful. This is applicable only when plate area is very large as compared to distance. The capacitance of spherical capacitor can be given as, now how do I find out capacitance of parallel plate capacitor? I just have to consider area of a sphere, which is 4 pi r square. So instead of A, if I take 4 pi r square, and instead of distance, if I take radius, what do I get? 4 pi epsilon 0 r. This is the capacitance of parallel plate, spherical capacitor. So for spherical capacitor, capacitance can be given as 4 pi epsilon 0 r, or 1 by 4 pi epsilon 0 may be considered as k, then it is r by k. So that is the expression for spherical capacitor. So that was the topic.